Assalamualaikum warahmatullahi wabarakatuh. My name is Nuri Izzati binti Ajizan. My supervisor is Dr. Muhammad Zahari bin Abdullah. I'm going to present my final year project titled Assessment on Heavy Metal Pollution in Surface Sediment of Kuala Perlis River. This is the presentation outline, which consists of 5 chapters. Background of study. This study area is carried out at a canalized stream run through the industrial area of Kuala Perlis to Kampung Sungai Baru in Perlis. The river length is roughly 7.24 km and the depth of the river is around 4 meter. Along this river, there are residential area, recreational area, industrial area and anthropogenic activities such as factory, power plant, paddy field, fish landing and water treatment. Problem statement. This area was chosen because previous research primarily focused on major river in a specific area such as Perlis River. The study of water pollution level in the small stream has become infamous, ignored and considered not important. Heavy metal can build up in the sediment, so they will have a negative impact on the surrounding environment and the nearby population. Therefore, evaluation of the heavy metal in the particular area is significant. Significance of study. The water quality index data obtained in this study will explain the readiness of the river to be used as one of the water resources for the local residents. Next, the result of the water pollution indices obtained in this study can be used to relate the water quality of the river with any activity taking place in the area. Next, the data collected from this study could serve as a reference for future research in the same field of environment. Objective of the study: to specify the water quality of the river water based on the interim national water quality standard formulated by the Department of Environment. To determine the pollution status and distribution pattern of selected heavy metals such as lead, cadmium, manganese, zinc, nickel and chromium in the sediment of Kuala Perlis River. To assess the potential source of the heavy metal pollutant in the sediment of the Kuala Perlis River by using contamination factor, enrichment factor and geoaccumulation index. Literature review. So this is some of the previous study that has been carried out. Methodology. For sample pretreatment, 10 sediment samples were evenly collected at 10 selected spots along the Kuala Perlis River during the monsoon season. The sediment sample were air dried for 60 days, then further dried in an oven at 80 degrees Celsius for another 72 hours. Samples were ground and sieved through a 2 mm sieve. Next, 0.5 gram of sediment was digested using aqua regia digestion method in a 100 ml beaker using 3 ml of concentrated nitric acid and 9 ml of concentrated hydrochloric acid. The mixture was heated on the hot plate for 2 hours at 100 degrees Celsius. The digested sample was then diluted with distilled water in a 50 ml volumetric flask. For each sample, 2 replicates were prepared. ICPOES was used to analyze the concentration of the chosen heavy metals. In terms of statistical treatment and data presentation, statistical analysis that was utilized in this study is including contamination factor, enrichment factor and geoaccumulation index. In situ parameter, there are 2 parameters, which is temperature and pH. In terms of temperature, the surface water temperature for the entire sampling site ranged from 31.7 degrees Celsius to 34.4 degrees Celsius with an average of 32.63 degrees Celsius. Considering it was very early on the day and this site provided the earliest sample, Station 1 had the lowest temperature. This station with the highest temperature was Station 8, which was situated in a residential area. According to the result, the temperature trend is rising from Station 1 to Station 8 and decreasing at Station 9 and 10. This might be caused by the station's lack of growth in tree. Station 9 and 10 are surrounded by tree, which may contribute to the station's lower temperature. For pH, the pH value for the surface water for the whole sampling station were in the range of 6.32 and 8.28 with a mean of 7.11. Based on the data obtained, several stations fall under class 1, which were station 4, 5, 6, 8 and 9. On the other hand, the remaining stations fall under class 2. The specification of the data obtained in this study is according to the interim national water quality standard. General trend of heavy metal. The mean concentration of the selected heavy metal across all sampling sites is as shown in the table. Based on the results obtained in this study, it was found that the concentration of the metal was not evenly distributed throughout the river. The most abundant metal in the sediment river is manganese and followed by lead, zinc, nickel, chromium and cadmium. Statistical analysis and data presentation. For contamination factor, which also known as CF, according to the range of heavy metal CF value, zinc has the lowest CF value, which measured at station 7, while cadmium has the greatest CF value at station 10. The degree of contamination is determined by adding the CF value for all the metal at each sampling station. According to the result, sampling station 10 has the highest value of CF, which is 213.4, while sampling station 3 has the lowest value of CF, which is at 61.8. The level of contamination for each metal has been ranked decreasingly according to the mean value of CF, which is cadmium, and followed by lead, manganese, nickel, chromium, and zinc. For enrichment factor, which also known as EF, based on the calculated EF value, almost all the heavy metals have level of contamination that are deficient to minimally enriched, in which EF value less than 2, and moderately enriched, which is EF value between 2 and 5, except for cadmium, which was found to have extremely high enrichment level, which is EF value greater than 40 at all of the sampling station. For geoaccumulation index, which also known as IGEO, IGEO value shows that most of the heavy metals at all study locations were categorized as class 1, which has an IGEO value between 0 and 1. On the other hand, cadmium has a different range throughout the entire sampling location and is categorized as class C with an IGEO value greater than 6. In conclusion, the entire sampling station has an average temperature of 32.6 degrees Celsius. Station 1 has the lowest temperature, while Station 8 has the highest temperature ever measured. The mean value of pH reading of all sampling sites is 7.11. By referring to the International Water Quality Standard, guidance provided by the Malaysian Department of Environment, half parts of the sampling station are categorized under Class 1, which means they are applicable for the conservation of the natural environment and require little to no treatment, while the other half area are defined under Class 2, which is sensitive to aquatic species and require conventional treatment. The order of the heavy metal concentration from higher to lower mean content is followed by manganese, zinc, chromium, lead, nickel, and cadmium. The CF value indicates that cadmium is most prevalent at station 10 and zinc is the least prevalent at station 7. The order of the pollution level is as follows, whereby station 10 has the highest pollution level and station 3 is the least polluted. The highest pollution level at station 10 is expected that it is because the sampling location is next to the paddy field plantation area and close to the residential area and main village roads. The river of the sampling area became the primary flow for the paddy field plantation water disposal. Consequently, the use of phosphate fertilizer, insecticide and pesticide in agriculture, the discharge of domestic and commercial waste, and the combustion of fuel by vehicles may all have an impact on the sampling location. The EF value of the majority of sample range from minimally to substantially enriched. Cadmium enrichment is exceptionally high at all sampling stations. According to the IGEO findings, the majority of the sediment sampling location are categorized as class 1, which is uncontaminated to moderately contaminated, whereas cadmium is classified as class C, which is highly contaminated. The potential sources of heavy metal pollution in this study is including commercial and domestic waste disposal, preoccupied road and construction fragments, transportation fuel combustion, cement preservation, untreated domestic wastewater, agricultural discharge, prawn paste production activities, social engagement, and regular application of phosphate fertilizer, lead arsenate, insecticide, and pesticide. As for recommendation, the result of the study can be enhanced by improving the sampling method and sample digestion technique. Next, advanced analytical methods such as ICP-MS, GCMS, and HPLC also can be used to analyze the heavy metal content in sediment samples. That's all from me. Thank you.